Hello there. My name is Dawson Peters, and this is my capstone presentation on creating public-facing energy resources for the Shoshone Bannock tribe and developing a wind power suitability analysis for the state of Idaho. So this project can be split into two distinct parts. For part one, Boise State University and the Shoshone Bannock tribe are partnering together to develop a collection of resources for the residents of the Fort Hall Reservation that discuss a wide range of energy topics. This spans from topics like large-scale wind power development all the way to how to help weatherproof your home to make it more energy efficient. Most of these resources were guided by a document released by the Tribal Department of Energy titled the Strategic Energy Plan. This document lays out past achievements and the future goals of the tribe as it pertains to energy. Our goal was to use this document as a framework to develop a story map that covers all of the content in the plan and acts as a repository for studies and data that the public can access to learn more about these resources. The second portion of this project is not within the partnership of Boise State and the Shoshone Bannock tribe and was conducted on my own. For this section, I performed a wind power suitability analysis for the state of Idaho. Renewable energy is a growing industry, and as Idaho looks to move away from hydroelectric infrastructure development, wind energy presents itself as a good option. Using GIS-based techniques, we can understand where suitable locations for these wind farms may be. Additionally, developing a framework to make these decisions can also help potential developers and government officials. For a story map development, our project consisted of 4 different phases. Phase 1 is data exploration, and this consisted of locating databases and new studies that showcased energy-related data that would be beneficial for inclusion in our story map. Some of the data found during this step is photovoltaic output feasibility, energy burden, and wind speed. Next, we move on to our narrative development. Here, we are referencing the strategic energy plan and deciding the best way to structure the current content and present it in a format that translates well to the story map interface. This section was made with the collaboration of tribal members so that we could accurately represent cultural values when discussing potential energy projects. We then move into our story map implementation. This step consisted of translating all of the work that had been done in a collaborative Word document into a story map. Here, we are making stylistic choices and adjusting map symbology to fit in with the rest of the content. Finally, we transferred our deliverables. Most of the maps and data have been placed in ArcGIS Online so that the tribe can make changes to the maps directly in addition to the story map. Also, as a part of our partnership with the tribe, all tribal data used had to be deleted off of personal devices as per our MOU. As of now, the story map is not publicly available as the tribe is still making edits, but here are some of the components. Feel free to pause the video to get a more in-depth look at the maps. Next, we move on to the suitability analysis. As mentioned, this portion of the project was not done in partnership with Boise State or the Shoshone Bannock tribe, and has the goal of locating suitable areas for potential wind farm developments. Using overlay analysis and the model builder function inside of ArcGIS Pro, we can make a model that can be implemented at different scales and adjusted for the rules and regulations of local areas. We will start with our inclusive variables, which consist of feature classes that our suitable areas have to exist in. Our first data set is the wind speed at 100 meters above surface level. This data comes from NREL, and our constraint is that the wind speed must be greater than 4 meters per second. To accomplish this, we reclassify the wind speeds with anything below 4 as a value of 0. Wind speeds 4 to 5 meters per second were reclassified as 1, 5 to 6 meters per second as 2, and so on. Our second variable is slope. We derive slope from a surface elevation dataset from the University of Idaho. Ideal slope for wind turbine development is anything less than 10 degrees. We then reclassified our slope data as anything less than 10 degrees as a value of 1 and anything greater as a value of 0. We then buffered our road and power line classes at 5,000 meters each and added a zone of 150 meters around roads where no development could occur. Our exclusive variables, or conflict zones, made up all of the areas where wind power development could not occur. This includes protected areas, which consist of places like national parks, wildlife preserves, and wilderness areas. Rivers and lakes received a buffer of 3,000 meters. Urban areas received a buffer of 2,000 meters for noise. And lastly, we have a buffer of 3,000 meters around airports. This leaves us with these two maps, all of our buffered exclusive features on the left, and areas that meet all of our inclusive feature criteria on the right. After this, we erase any areas where there is overlap, and that leaves us with our final map. This displays all of the remaining areas that are suitable for wind power in Idaho. Each of them is symbolized with their wind score and what wind speed that score corresponds with. Most of the sites are concentrated in southern Idaho. Lastly, we have our suitability analysis model. This tool can act as a framework for us to adjust variables as needed and change the boundaries of the study for a smaller area if necessary. Overall, we have a strong model that gives us an idea of potential sites for wind turbine development and can be expanded upon to account for such factors as land ownership and local wind turbine regulations. Thank you for listening to my presentation on creating public-facing energy resources for the Shoshone Bannock tribe and developing a wind power suitability analysis for Idaho.